Okay, we will be starting with the session now. Hello, everyone. Dear authors and invited guests, welcome to Technical Session 6C. I am Dimahi Patel, and this session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 10th International Conference on Information and Communication Technology for Intelligent Systems, New York, USA. The 10th edition of this conference is being organized in a hybrid mode. The physical event was held yesterday in New York, and the virtual event is being held through Zoom yesterday and today, that is 23rd and 24th May 2025. I hope you will enjoy the knowledgeable and interactive sessions through the day. In this session, we have 8 presentations. Each presenter will be given 12 minutes for the presentation and 3 minutes for question and answers. On 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Before we start the session, I would like to introduce you all to the chair for the session. We have with us Professor Pop Emilia Loredana as our session chair. She is a lecturer professor at Babes Boli University, Faculty of Mathematics and Computer Science, Napoca, Romania. Her expertise covers databases, optimization, education, web programming, and artificial intelligence. She is dedicated to advancing both theoretical knowledge and practical applications in computer science and education. We welcome you, ma'am, and I request you to share any few words you may have for the presenters today. Ma'am, your mic is muted, ma'am.
Hello to everyone. I am so sorry. Thank you very much, first of all, for having me here, for this honor. I would like to wish success to all the participants, but most of all, I would like to congratulate everyone for the great work they have done here, and I wish to hear their presentations. Thank you very much.
Thank you, ma'am. We also have with us Dr. Anubha Jain as our session chair. Dr. Anubha is working as a director of School of Computer Science and IT at IIS deemed to be University Jaipur. An academician for the last 22 years, she has actively contributed in teaching, industry, and R&D. Her research interests include soft computing, computational studies, IoT, and software engineering. She is the author of 9 books and has published a number of papers at as national as well as international level. Welcome, ma'am, and please share a few words you may have for the presenters.
Thank you, Bhumani. Thank you for the kind word. At the outset, I would like to congratulate all the organizers for organizing such wonderful research conferences and for promoting research across the world. And I wish all the best to all the participants who are here to present their research with us. And I also wish best wishes to all my fellow professors, professor from Romania. Thank you very much. Looking forward for a wonderful interaction with everybody.
Thank you, ma'am. We will be starting with the presentations now. I would like to call Abdullah Al Shoshan, sir, to present their study on a writer identity verification and identification system using invariant script features. Abdullah, sir.
Yeah, hello, everyone. Is the slide shown on the screen?
We can see the black screen at the moment, sir. Yes, sir, your slide is visible to us.
Good. Thank you, Professor Pope, and Jane and Patel for chairing and moderating this scientific session. And good morning to everyone who joined me at ICTIS 2025, which brings together a selected group of researchers that are from around the world. My presentation is a summary of my paper titled identity verification and identification system using invariant script features. Uh, Actually, the verification and identification used widely, most of them are visual verification or identification, such as fingerprints, iris, retina, or signatures used in banking, airports, or authorization access to some places. And they are very helpful since they are simple with simple tools, but are all considered static verification, and they don't contain hidden dynamic information of the person of interest. Therefore, it can be forged by frauders or fraudsters. So hidden dynamic information is needed to increase the rate of correct verification and identification of the person. So in my paper here, I will, this is the outline of the paper. Uh, I will give a quick introduction to the paper. Then I will scan the features that I used in the verification and identification. Then I will just show the system and the results at the end. So just at the beginning, you know that identification means that who are you? So it is 1 to n match. However, verification are you this it means that are you who you claim to be? So it is just 1 to 1 match. So in the paper, we are trying to verify or identify the person by its scripts or writing. So these are, for example, the visual verification that are used in common places. And this is example of signature that or script that is added to the paper to verify the person. So we compare the features of the script, not the script itself, with the feature of the script of the new signature or script, compare them and check the results. At the beginning, I will start with the online dynamics, then offline dynamics, then I will show the statistics of correct and wrong verification. I will start also from the end. This is the end of the system. So I have inputs. I use stylus to collect the dynamics of the script. Then I use the feature extractions. In this paper, I will use the, I will call it dynamic or hidden features, the speed and acceleration, and the offline or the static NFD for normalized for a descriptor and normalized central moment. Then I will store them in the database and compare them in the future. So feature extraction, the first features are the speed and acceleration. So I use stylus to find the speed of the signature because you know that when you write any word like signature, you start slowly, then in some places or some portions of the script, you speed up, then you finish the script. The the forgery cannot cannot know the speed of your scripts. So this is example of the speeds that for this script, which this is some samples. You see that they are closed, and the person increased the speed in this portion and decrease in some places. And this is example of the acceleration, which is the first difference of the speed, example of this script. So these are the dynamics that are hidden and need stylus uh, to be recorded. So I used them. The other offline, or we can call it visual script verification, uh, are the normalized central moment. I'm not going to go in details with the math. Anyone who is interested in the normalized central moment, for example, should refer to the references who paper. So these are the equations of the moments. So we calculate the first the moments, then central moments, then the normalized or invariant moments, and low or who sorry proposed 7 moments. He said that it is enough to be unique. The features should be invariant to scaling or rotation or shift. This is what I have done in my research. So I choose to have the invariant features. So this is the moment. For example, this is the 7 moments of this script. This is the 7 moments also of the other script, ISAM. We see the differences, and we will see that even if we rotate the script or change the size or the location of the script, it will give us a close invariant moments. The main problem I found in the invariant normalized central moment is that it is sensitive to the ratio between x and y. The advantage of the central moment or the moment is that it takes all the points in the image. So it includes the internal details of the image. The second offline feature is the normalized Fourier descriptor. And maybe if some of you are familiar with Fourier transform, this will be clear that we take the Fourier transform of the script, but we have to pre-process the script. So this is the first step. Second step, we take the boundary, then we convert it to a 2D complex function. Then we take the Fourier transform and make some processing, removing the phase shift or rotation or translation using Fourier descriptor. Anyone who is interested in the boundary of the shape can go back to Timothy Wallace and Paul Wayne's paper. They described this in details. And the beauty of this descriptor is that it is insensitive to scaling or rotation or shift. This is example of, of this script. So this is the original script. This is rotated. This is shifted. This is the second one, sorry, scaled by 3. The last one is rotated by 90 degrees. After getting the normalized Fourier descriptor and coming back from Fourier domain to time domain, we see that it returned them to the original one. So we can use just template matching after we come back from Fourier. The script also can be applied to other languages or any language. For example, Chinese, this is example of the word tree, I think. We take the boundaries, then we take the Fourier descriptor, so it will be unique. It has some problems since we are taking the boundaries, so we will ignore the internal details. For example, the mother in Chinese is like this. If we take the boundary using to use the Fourier descriptor, it will be like this. So it has problem in the internal details of the image.
Hello. Sorry for
Yeah.
interruption, sir, but this is a gentle reminder that you've crossed your 10-minute mark.
Okay. These are the samples of the database. This is the results of comparing these features with the 350 samples. And we see that the speed is the best one because the forgeries cannot use the same speed even if they can draw the same image. So in conclusion, I just reviewed the dynamic and static features, try to find invariant features, so changing the size will not affect the recognition. I found that there are problems in each one. For example, the speed and acceleration. You have to be careful about stopping the points or the timing. The main problem in normalized central moment, I said the ratio between x and y should be the same ratio to compare. The main problem with normalized Fourier descriptor is that script must be one piece. Script intersection is ignored. The outside boundaries are the only information we have in normalized Fourier descriptor. And thank you. These are the references in the paper, and thank you very much for listening. If you have any question, you are welcome.
Emilia ma'am, any questions for sir?
I found the paper very interesting. Thank you for having it with us, and also the mathematical formulas. I would like to ask something related to this script that you have presented to us. What do you think you can do for the future? Can you apply
Yeah,
more?
yeah. I think if you are interested in the internal details of the image, the best way is to use normalized central moment. If you are caring about the boundaries, like in Wallace paper, they were concentrating on airplane shape, the boundary of the airplane, or even the character recognition. If you are taking the boundaries, it will be very helpful to use normalized for a descriptor because it is not sensitive to rotation or scaling or translation. So anyone who is like some of them, they are using it in agriculture to recognize the fruits and also in industry to recognize the tools or something like this.
Okay, thank you very much.
Thank you.
Very convincing.
Thank you.
Anubha ma'am, any questions for sir?
Yeah, yeah. I just want to ask the number of samples you said were 50, right?
Yes, the samples
Are
I
you
used.
planning to increase the number of samples? Otherwise,
Yeah,
the result may be biased.
yeah, you are right. I feel that يعني 350 350 is low. But as we increase the number of samples, the results will be more accurate. You are right. So I'm planning to increase the number of samples.
Yes, this is my suggestion to you that we should try to incorporate more samples.
Yeah, excellent notice. Yeah, thank you.
Otherwise, it is very interesting topic.
Thank you, Professor Emily, and thank you, Patil. If
Thank
anyone
you.
of my colleagues would like to ask, and good luck.
Thank you sir for your presentation.
Thank you very much.
Next, I would like to call Zhang Lai Nok sir to present their study on computational approaches for logical biomolecular complexes design for cancer treatment, a preliminary study.
Yeah, sure. Can you see the PowerPoint file right now?
Yes, sir, your presentation is visible to us.
Yeah. So first of all, I want to thank for having me in your conference, and thank to my teacher, the Mr. Rajiv Khan. And Today I will represent my preliminary study about the cancer treatment. And uh, the problem start from when I observe the natural creature. They can make the very complex decision without learning or without even with the in the cell level. You can see like some bacteria without the brains, they can make a complex decision. So actually there's algorithmic logic behind their molecule mechanism. And the question is, can we use that? Can we introduce the programming concept to the biology system? And I start from the virus. Actually, the virus, they have the logical framework, which is embedded in their layer structure. The outer molecule will carry the function before the inner structure, inner molecule. For example, if the virus, they want to enter the cell, they need to have the protein to hijack the motor of the host cell to bring them inside. And when the RNA or DNA exposed to the cytoplasm, they need to have the code to tell the host cell like, hey, this is the starting code. You need to start make more and more copy and assemble me to the fully function virus. So the question is, can we learn from this strategy to synthesize the artificial device, which is embedded a logical program on it inside it, but not for multiplication or spread, but for cure our disease. So this is a schema that I mentioned here. Like we call them, this device is a logical biomolecule complex, and I would like to call this the complex. The same with virus. You need to embed the structure that makes sure the complex can be carried inside the cell. But when inside the cell, the most important thing is you have a sensor here. Here the sensor can be a RNA, which is close by a protein. And this protein is binding strongly with the mutation protein. When they detect the mutated protein inside the cancerous cell, it will be release the RNA strand, and the RNA strand will say like, hey, this is the therapeutic program, and the host cell need to implement the program. However, inside the normal cell, because the lack of the mutated protein, your sensor cannot be open. And like, because inside your normal cell, they have some defense mechanism that will it deletes the abundant RNA after a while. So after a while, your molecule will be degraded safely. And to build that, actually you need to solve two key tasks. The first one is you need to choose the component of your complex. For example, for the cell, the RNA and the protein. And the second one is you need to make sure that there is no molecule in the cancerous cell can inhibit your complex. And actually, right now, there's many computation tools that can help you to calculate this interaction. They are include the molecule mechanics, quantum mechanics, and newly the machine learning, and they are developed very quick. So right now they can predict the chemical interaction very accurately. So for let I say like this is a concept like if you introduce a complex inside your cancerous cell, you need to check if there is any molecule inside the cell can inhibit the working of the action of your complex. And in the B figure, this is the a structure of the complex, which include the liposome or the fat membrane with protein protect for the RNA strand or DNA strand. And here I depict a situation when you can use the cell therapies to as switches, like to censor the mutation. The KRAS 12C is very famous mutation in cancer, and the scientists developed the sotorasib as an inhibitor, but there's many problems because the sotorasib cannot eliminate the cancer totally, and it's gradually develop the resistance. So here I suggest that we use the sotorasib like a switches, and we divide the function in two parts. The first part is to detect the cancerous cell inside the cell by sotorasib, and the second part is eliminate the cancerous cell by the RNA, by the program in the RNA strand here. And this is the comparison between the oncolytic virus and the LBC complex with other treatment. Like there are two special things about them. The first one is they send the mutation inside the cell, so they are very highly specific. And another thing is because your RNA, they contain a program, so it can multiply themselves and amplify their copy inside the cell. So it's overcome the dose limitation. And this is my content. And here is the answer address the comment. So the first one is the clinical translation, how we can apply it in the hospital. So in the hospital, because it's a program, you can program it, so you can choose many logical framework. But for clinical translation, you need to make sure that the customization is as least at less as possible. So we offer an approach that we mimic the immunotherapy, but we do not use the immunocell. So for the step one, you just encode a marker inside your RNA, and once go inside the cell, the RNA will be translation, and it will release the marker to the environment surrounding the cancerous cell. It say, hey, this is the size of the cancerous cell. And in a step two, you just use another medicine, which is one go inside the body, it will realize the marker and only release the toxicity or the medicine at the treatment site. So I could take the 5-FU to as the marker, and the CDate as the marker, and 5-FC at the medicine. So when the 5-FC find the CDate, it will be convert to 5-FU, which is normally medicine that we use in chemotherapy. So this one is very good because you can use for the patient who have the immunodisorder, like the elderly, the lupus, or even the HIV patient. And also the only thing you need to design is the switch which realize the cancerous cell.
Excuse me, sir. Sorry for interruption, but this is a reminder that you've crossed your 10-minute mark.
Okay, I will finish soon. Okay, so this is I also share you, like we already have many type the switches which found in the nature, and we can engine them to our switches. And actually, all of them are actually have a if-else clause inside their structure, which can really make the programming concept feasible on the biology system. And for the challenge, this is a room for creativity solution. And thank you. And if you have any question, please tell me.
Amelia ma'am, any questions for sir?
Thank you very much for this presentation. Actually, I found it very interesting due to all the techniques presented. I'm a little curious about the fact for future for the appliance of all these. How are you going to think about storing the protein, RNA, and to perform more deep analyses?
Uh, for storing, I also know like they concerned about that, and they are trying to develop the artificial molecule, which is totally do not contamination. For example, they not use a natural RNA. They use another kind of sugar to make the RNA strand. So when this molecule go inside the body, it cannot spread outside, or because it's very early problem. So so far as I know.
Thank you.
Yeah.
Anuma ma'am, any questions for sir?
Yeah, no questions from my side. All the best for your research.
Yeah, thank you.
Okay, thank you sir for your presentation. Now next I would like to call Julian Andres Duarte Suarez sir to present the study on data log, Internet of Medical Things applied to home hospitalization as an e-health service.
Yes. Good morning, everyone. It's a pleasure for me to present the data log project that Maritalization as a tool for electronic health. My name is Julian Andres Duarte Suarez. I was the author of the article in question along with the teacher and engineer Leonardo Juan Ramirez Lopez, and I hope you like data log Internet of Medical Things applied to home hospitalization as an e-health service. Here we can see the content of this presentation. In a summary, we will analyze from the problems that motivate to develop this project, and therefore we will see which parts integrate the proposed solution called Datalog. This project was developed at the Universidad Militar Nueva Granada, which is based in the capital of Colombia, Bogota, in an RV headquarters in Cajica, Cundinamarca, 40 minutes from Bogota. Here is our working group, which is called TIGUM. We have different profiles that keep constantly to this type of projects, providing their knowledge and opinions in order to achieve the expected results. And thus we have our lines of research that generate great scenarios of innovation. As I mentioned, we start from an initial problem, which triggered on the one hand the pandemic, and on the other hand, the great functional and operational delay that generates the technological need of implementation that hospital have, causing overload of income, low efficiency, and therefore negative affecting the patient and even the conditions that the medical agents have to provide clinical service. This is the question. This is the principal question of this project. How can early warning system based of vital sign analysis, categorized by colors and supported by data meaning, improve medical intervention and reduce emergence in the home hospitalization setting? Datalog is based on IOMT, Internet of Medical Things, which in a few words is the use of several devices that are connected through the internet and allow communication and data flow, regardless of the distance between them. These facilities the creation of the hospital environment from the patient's home, which according to studies was shown to reduce the risks of infection and thus optimize hospital resources. In this way, Datalog wants to improve the conditions and tools for everyone interested in achieving an intelligent hospital, improving decision-making, providing help and support to certain clinical tasks. Here you can see the architecture of Datalog. That is based in 4 layers: perception layer, network layer, processing layer, and application layer. This is the diagram. To capture the data in Datalog, we have our disposal the use of the group of device and software called MySignals, which was wireless sensors and wireless sensor. In this application, we use two for each category. For wireless sensors, we use a sensor that measures pulse and oxygen, and another sensor that measures blood pressure that are decomposed into variables, diastolic pressures and systolic pressures. From wireless sensors, we use an airflow sensor and another temperature sensors, thus achieving the capture and subsequent monitoring of 6 physiological variables. Here we have a system made with the help of Dr. Norman Jaimes, which showed to categorize by color different states of patients to promote the diagnosis and generation of preventive alerts. As you can see, we have ranged in the event that the values fall, taking into account the normal values of rise. Likewise, the idea with this classification is to use it for monitoring and prediction graphs. Already in development, we have the connection section. We verify that the wired and wireless sensors are working, then they process them. I should be noted that in Datalog, we use 3 environmental variables are also measured to obtain future conclusions and influence according to the patient's condition. These environmental sensors are in a ECP32, is connected via a USB cable to the Raspberry. Before using the simulators, Datalog search for information in a public database in order to have a reference on the behavior of the select variables in scenarios where the patients suffer from cardiac and respiratory pathologies. After the capture, an essential part in Datalog is the deployment and was the way to make the prediction. For that was used a reference Weka software, where initially test files were entered to analyze all the features and models of Weka. It was concluded from all tests and reviews that the best model to obtain the forecast was the model of time series whole winters, whereas you can see the time labels with asterisks are forecasts of these variables. In this case, the temperature and ECPO. Now, in this part, we have the visualization where at the beginning with Weka, we have a forecast plot just when it analyzed the whole set of data. Under this discussion with the Tigun group is what considered that was not the most viable because we will have to wait a lot to able to make the preventive diagnosis. Therefore, was determined was to be able to make partial prediction by analyzing the data to be captured. In this graph, we can see how from the classification table, for colors, seen above the trace shown in the graph. With those evaluation and analytical process, we arrive at the interface that make up the web application, where each role, patient, doctor, and administrator has a specific user and has access to certain windows. In this case of the patient, can observe the monitoring of their vital signs, and also iris window are include alerts when the values are not in normal range. Finally, a fundamental area in development of Datalog was bioethics and security. Science handling of sensitive patients data through IoT system, such as data log, entails important responsibilities in terms of privacy, security, and ethics. We are well aware the IoT device can present vulnerabilities, and the cost of a healthcare data breach can be exceptional high. Therefore, data law is being developed with a strong emphasis on bioethical principles. Finally, we have the conclusions. This project, this data law, prove that validation of system with public database and medical simulation robots ensures
Excuse me,
data
sir.
law.
Gentle reminder of your crossing 10-minute mark.
Okay, thank you. Ensures data law accuracy before it is applied in real-world smart hospital environments. Second, data logs offers a new alert system based on color code patients status classification. And data log is not only combines as a logical analysis of data, but also capable of generating prospecting analysis. Thank you.
Amelia, ma'am, any questions for sir?
A very interesting application with the practical part for Colombia, if I'm correct. You said about the prediction. You did a lot of prediction. How, I don't know how many patient. How did you perform this part?
In the section of prediction, we have evaluated different models of the software Wika. Like you can see Bayes functions, regression models. In conclusion, and finally, for all the tests, Tigun, we have a conclusion that the best model to use in this application is the whole winters.
Okay, thank you.
Anubha, ma'am, any questions for sir?
Yeah, okay. Congratulations on such an interesting research. I just want to know, ki, how will you be able to address the security challenges related to this particular application?
Sorry, repeat.
What are your plans to address the security related challenges to this particular IoT-based application?
The principal well, in Datalo, we applicate different statements in terms of security. We have a firewall specification. We have the military zones. In terms of ethics, we have the consider the importance of simulation to the data and to the privacy data. And yes.
Thank you.
Thank you, sir.
Thanks.
Now, next, I would like to call KPNS Dayarathne, sir, to present the study on deep learning approach for predicting interest rate behavior in dynamic capital market, South Asian frontier market. Dayarathne, sir? Yes, sir.
Hope I'm audible.
Yes, sir.
Okay, thank you for the opportunity. So my study is named as the Deep Learning for Interest Rate Prediction for South Asian Frontier Market. My study is being done along with my professor, Dr. Uday Sangataisim as well. I'm from Sri Lanka. So let's try to move why interest rate is pretty important for a country. There are a couple of reasons where it is important for general public to where the economy is directed, and also the central bankers, the policymakers, where the interest rate is picking up. That is because of some of their target is to modern Sri Lanka. The world, some of their target is basically to forecast the inflation related interest rate prediction. And also it is very important for the other people who are in the business world and other people who believe to invest in a sort of a project where what would be their target interest rate and what are their returns as well. Uh, Given all those things, it is important for the country people also, or the policymaker, not only policymakers, the government also, because the increase of the interest rate would basically increase their payments for the debts. So Sri Lanka went through the debt crisis. That is because of we didn't manage to contain the interest rate in an appropriate manner. So in a larger scale, prediction and studying the interest rates is pretty important aspect in any country. So when it comes to the interest rate study, there are three main dimensions of the studies. One is the time series analysis, where the univariate analysis has been considered, which is my main study. And also, we call it as a sort of a multivariate time series, because not only one instrument's interest rate is being considered, there are multiple instruments with regard to interest rate need to be assessed. So that is a multivariate time series analysis. Other one is a combination of time series and the other instrument, which we call it as a panel data analysis. So my study is mainly focusing on the univariate time series problem. So if I try to define my research problem, where when it comes to the frontier market, especially countries like Sri Lanka, when it comes to South Asia, Sri Lanka, Bangladesh, and Pakistan, historically there are the data is sort of a lack. And also, not like the Western countries, which has a far more depth debt market, we have a substantial higher volatility. And also, there are less focus on univariate analysis. More people try to go with the multivariate analysis, but we believe that in countries like frontier market, we need to look at it where the 3 months interest rate is moved and also where the 10-year interest rate is moved. So developed countries both moved somewhat similar, but there are differences when it comes to the frontier market. And also, when it comes to applying the traditional time series model like ARIMA, SARIMA, and some smoothing method, those models is unable to capture the complex dynamics changes in the interest rate, especially on the frontier market. With that, we define our research objective, how we can identify machine learning and deep learning models to suit to predicting the interest rate, and forecast the univariate time series using deep learning models, and try to evaluate it is across 3 main countries, which is in South Asian frontier market, Sri Lanka, Pakistan, and Bangladesh. Then try to identify what would be the best fitted model for different market conditions. So if I go through the literature review, the general overview is that univariate time series analysis is basically based on the historical past data of the same variable. And traditional models are ARIMA, and also the vector autoregression and vector error correlation models also being used in this aspect. Machine learning algorithm is far more better than the traditional time series models, but deep learning is going to be overtake the machine learning algorithm because of its some of the weaknesses. But when it comes to the analysis, always there is a limitation in the studies where the some of the applications, instruments are pretty much less in the frontier financial system. So if you look at the traditional application of the univariate time series modeling, ARMA and the VAR model is being mainly focused on. Vector correlation models also has been used in different conditions along with some Granger causality tests, try to test the lag period also, and Arch and Gauge models also have been used. But the common concern in these studies were the low predictability and the accuracy, but given the explainability high, but the accuracy level is low. And if you look at the approach of the machine learning and the deep learning algorithm, most of people have used RNN and CNN and LSTM, which are substantially give the much more higher accuracy than the traditional machine learning algorithms also. But the problem is that most of those algorithms have been used in the most developed market. But when it comes to the frontier market, where the high volatility is there, abnormalities is there, and ups and downs are pretty much high. So lot of people has not really concentrating in these countries using the deep learning algorithm for these countries. One is the lack of data, and other one is the lack of instrument. But due to the technological development, the data is now available for these countries for us to go with the much more deeper analysis. So in this study, I have used the RNN and LSTM and CNN and TCN models to basically try to find out what would be the best one depending on the market condition. We know that the Pakistan, Bangladesh, and Sri Lanka have their own different depth of the economics. So we try to use it, try to test whether these for these models would be approaches those different countries. So if I just try to brief the data sets, we are depending on the government securities rates, and time period is also different for Sri Lanka and Pakistan. We were able to extract from 2010 to 2022, but Bangladesh slightly lower than time period. And we try to predict the interest rate for 3 months, 6 months, 1 year, for up to 10 years. So if we try to just brief the data set also, data set would like this, the graphical representation, but every 3 months, 6 months, 1 year, the data look like this. So it has varying, but each tenor or each instrument is have some sort of a correlation, but does not behave in a similar manner. So we adopt the data pre-processing process. Usually discounted interest rate cannot be used for this kind of analysis. Therefore, we have to derive the zero coupon bond. And usually when the interest rate is substantially deviating, we'll have to do the normalization, and train and test data is being used. And since we are using the machine learning and deep learning algorithm, we have to go for hyperparameter tuning, and we'll have to look at what are the sequence lengths and try to change the activation functions also. And we have used the RMS for the assessing the model. So these are the basic structure of the algorithm, and I don't want to jump into the more detail because of the time limitations, but there are inputs and outputs. There are different layers that will be cross-check how far we need to look at the data, whether it's a 3 months prior data is enough or whether 6 month prior data enough, and then we come up with the output sequence. So let's try to look at what are the results which is related to first Sri Lanka and Bangladesh. We have found that the CNN is basically outperforming all the other models compared in this study. And if you look at the after that, what we thought of, rather than try to focus on other models, we concentrating on the CNN, and we try to change the activation functions and change the pooling also. And we found that RIL and the max pooling has been generating much more higher accuracy levels in Sri Lanka and the, Bangladesh. And if you look at the overall situation, not
Excuse me,
compared
sir.
to, yeah.
Sorry for interruption, but you have crossed your 10-minute mark, so this is a gentle reminder.
Okay, so Pakistan, the model for the Pakistan was LSTM, and Bangladesh and Sri Lanka, it is the CNN, which is being better than the other model. So if you look at the Sri Lankan results, CNN performed better than the other instruments. And if you look at the inside of the rates also, short-term interest rate have a much more higher error term, but the long-term interest rate at a much more lower error term. So if you look at the Pakistan, LSTM outperform all the other instruments, but in the Bangladesh, again, the CNN basically outperform well. And if you look at the final outcome, CNN is basically short-term dependencies is being properly captured, and LSTM as the technically also then try to look at the long-term memory by using the historical, much more larger historical data, but it seems to be capturing the higher volatility in these countries. And it is very important to understand the country dynamics before we apply any sort of model, because the country dynamic play a major role when it comes to selecting the different algorithm as well. So when it comes to the limitation, I have only depending on the univariate analysis and external economic variable has not been considered that. And also during the this particular period, higher volatility creates some sort of a distorted in the data. And in order to look at the future works, we would have, I would have basically looking at extending this study for bidirectional LSTM and try to see whether auto encoders can be used, and some of the variation of the neural network also can be improved. And further step would be the looking at how we can apply these things into the multivariate approach in predicting the yield curve. So that's it. Thank you. I'm happy to answer any question.
Emilia ma'am, any questions for him?
I consider the presentation very, very nice, and also the comparison to the methods used was very, very useful. I would say, do you think about extending more this research of adding other countries from Asia, or maybe from Europe, or why not US?
Yes, yes. I concentrated mainly onto the Asian frontier market, which I am also from Sri Lanka, to capture some of the variation and the countries has been gone. Yes, once I completed the other models like the bidirectional LSTM and other advanced neural network, machine learning and deep learning approach, of course, I would like to look into other countries as well. Yes.
Thank you.
Anubha ma'am, any questions for him?
Yeah, I just want to ask one thing, that country-wise, you are finding different algorithms outperforming others. Can you think of a reason why is it so?
Yes, I believe that mainly because of the different countries, even though everybody's been categorized as a Asian frontier, South Asian frontier market, still these countries as when it comes to the capital markets, level of development is different. Therefore, the relationship between the 3 months interest rate along with the 6 month interest rate and how these short-term interest rate behave and long-term interest rate behave are different. That is why I believe that some of the models work better in some countries and other models is better in the other countries.
Okay, thank you.
Thank you very much.
Thank you, sir. Now, next, I would like to call Teiko Onodera ma'am to present her study on logic extraction from AI models using the Quine-McCluskey algorithm for human clinical decision making.
Good morning, everyone. It is a great honor to be here today at ICTIS. First, I'd like to express my sincere gratitude to Professor Emilia and Dr. Jane and Professor Peter for hosting this session. Thank you very much. And my name is Taiko Onodera. From Tokyo Heisei University, Tokyo, Japan, and Kotaro Hachiya and Yuhei Hatakenaka. Today I will present from AI models using the Quine-McCluskey algorithm for human clinical decision making. Background: with the advance of machine learning, its use in medical and welfare fields is expanding. However, actual adoption in clinical practice remains rare. This is due to limitation in reliability, explainability, privacy protection, cost effectiveness, and medical device certification. Our goal is to derive human readable rules from machine reading models to support manual clinical judgment. I compared three traditional methods. One, point score system was using a logistic regression. Two, posterior probability using a likelihood ratio. Three, logical expressions based on route theory It has strengths, but also limitation in clarify and usability. Using logistic regression, we model the relationship between features and the probability of a positive outcome. The logic function helps us determine whether the outcome is likely to positive. In practice, we simplify the equation using rounded integers. This method calculates posterior odds using prior odds and likelihood ratios. It's widely used in evidence-based medicine. The case is judged as positive as the posterior odds exceed the threshold. Next slide is this approach drives logical contribution that always lead to positive or negative classification. It constructs decision rules from observed data without needing probability distributions. And next slide, after building a machine learning model, we input combinations, qualitative explanatory variables, and obtain the outputs. These results are compiled into a truth table using one-hot encoding and logic synthesis algorithm. We extract a sum of products expression. The QM algorithm simplified the logical expression to their minimum forms. It guarantees minimal representation, but has exponential time complexity and be hard. It is well suited for small to medium scale Boolean expressions. Evaluation method. We compared for rule extraction method using open data. 1. A point score system rule. 2. Likelihood ratio. 3. Last-set theory. 4. Our proposed method. Machine learning is random forest used in this study, plus the QM algorithm. We evaluated both the interpretability, rule count, and the accuracy of each method. We use a data set of 120 patients with expert diagnosis and 70 features. The classification was binary, depression versus others. Target variables, expected diagnosis, classified bipolar 1, bipolar the second, depression, and normal. This study, depression versus others binary. Oh, I said it again. And features include variables such as sadness, euphorics, exhausted, sleep disorder, mood swing, suicidal thoughts, anorexia, authority, respect, try explanation, aggressive response, ignore and move on, nervous breakdown, admit mistakes, overthinking, sexual activities, concentration, optimism. These features are consistent with DSM-5. Point score system. Rule example. Here is the example of a rule using 4 variables from logistic regression. Less important variables are eliminated, and the remaining are used to compute a score. Accuracy was evaluated with 4 variables. Posterior probability calculation using likelihood ratio. We multiply the LR value for 4 variables with the prior odds. If the resulting posterior as exceeded said threshold, the case is classified as positive. Threshold of 0.426 in this case. A logical expression based on love set theory. One of them is mood swing is no, and euphoric equals seldom, and overthinking equals yes, and so on. These rules are evaluated by coverage rate. Accuracy was tested with 4 terms. Since the conditions derived are always positive, the precision is always 1. We use a clinical and logical formula based on the proposed approach. Our method generated logical express top 4 features, random forest importance, and simplified with the QM algorithm. Only 4 terms were used per word. Mood swing, and one of them is this one. And we use a clinical utility index CUI to access screening performance. CUI plus equals sensitivity times PPV. CUI minus equals specificity times MPV. Now, let's look at the CUI value. This area, poor, and this area is excellent. Above 0.81 is excellent area. Only our method achieved CUI values in the excellent range with just 2 or 3 rules, 1, 2, 3, and 1, 2, 3. And CUI plus recall times precious aligns better with clinical screening utilities and has clear interpretation evidence based on medical discussion. Our method produced the high CUI with superior rules compared to existing method.
Excuse me, ma'am. Gentle reminder that you've crossed your 10-minute mark.
Okay. And ML model is understandable rule. Limitation, excitation time increase exponentially with more variables. Future work includes heuristic simplification method. Conclusion, we propose a method to extract human readable rules from machine reading. In your depression diagnosis case study, only our method reaches CI plus greater than 2. 0.81 using just 2 or 3 rules. This shows its strong potential for clinical AI support. That concludes my presentation. Thank you. I'm happy to answer any questions you may have. Please simple English, please.
Amelia, ma'am, any questions?
Well, thank you for the presentation. I found it very interesting, especially because you use that QM algorithm and also the math and the regression. I would like to ask you a little bit about that clinical utility index that you told us about. How exactly is this one used? And yeah, how it is exactly used?
Okay, thank you very much for your questions. And CUI means CUR reflects clinical usability better, especially in screening task. CUI plus equal recall multiplied precisions arise. But if score is average, and I think better with clinical screening utility and has clearer interpretation and evidence-based medicine. And Q algorithms, we use the QM algorithms It's because it guarantees minimal expressions improving interpretability. Thank you very much.
Thank you.
Anuba ma'am, any questions?
Yeah. What are the future prospects of your research?
Oh, you mean the next search future? Yeah. So,
Future prospects of the research.
next search. We received feedback from one of our co-authors who is psychiatrist. However, since the findings haven't been generalized, we needed more thorough investigations. Thank you very much for your asking.
Thank you.
Thank you, ma'am. Now, next, I would like to call El Haji Basiru Tor sir to present their study on microflex, flexible consistency management in microservice architectures through mega model-based state transition rules.
Okay, hello everyone. Hello everyone, I am El Hadji Bassirou Touré from University Cheikh Anta Diop in Senegal. Today I want to challenge a fundamental assumption. Should we sacrifice consistency for autonomy in microservices or autonomy for consistency? Today I present Microflex, a breakthrough that resolves this conflict. Microservices promise scalability, but force data duplication across services. This creates our fundamental challenge. How do we
Sir, your voice is lagging.
duplicated data when each service has its own copy? Current approaches force a binary choice. Do you hear me well?
Yes, sir.
Okay. Current approaches force a binary choice. Strong consistency destroys autonomy. Eventual consistency offers no formal guarantees. Current solutions like 2PC, eventual consistency, and saga patterns all force this binary choice between consistency and autonomy. We need a fundamentally different approach. Here is our solution. Microflex breaks this binary choice through component level consistency.
El Haji, sir, can you hear me?
Yeah. And do you hear me?
Yes, sir.
Okay. I'm sorry for this. Yeah, our solution Microflex breaks this binary choice through component level consistency control. Our key innovation extending MSI cache coherence with differentiated shared states, share plus for fully consistency, share minus for bounded staleness. This allows services to continue operating with formal warranties. Our mega model serves as a coherence directory tracking consistency states and metadata, not data, just metadata across distributed services. We formally define microservice systems where each service component pair has its own state and consistency type mapping, enabling fine-grained control. Four states: modified, shared plus, shared minus, our innovation, and invalid. there are these 4 states that we used, combined with 5 consistency types from strong to eventual, enabling business-driven choices. These 4 consistent steps are strong consistency, eventual consistency, boundness, staleness, monotonic rates, and read-my writes. Now, the mathematical precisions that makes this possible. We define 5 operations triggering from former state transitions. The key insight: when updates occur elsewhere, strong consistency components become block, while relaxed components transition to shared minus and continue operating. This provides mathematical precisions with deterministic transitions, bounded staleness guarantees, and enables formal verification. Distinguishing us from ad hoc solutions. Global operation models specify that the same duplicated component can have different consistency requirements in different application contexts. Our algorithm handle update propagation and refresh operations with multiple conflict resolution strategies. To prove this works, we applied Microflex to e-commerce with 5 services requiring different consistency levels. Financial data needs strong consistency. Inventory uses bounded staleness. Catalog uses eventual consistency. This table shows our approach in action. Our model, other model and payment model require strong consistency for financial integrity. Inventory model uses 30-second bounded staleness. User profile model needs read my writes. Product model uses eventual consistency for maximum availability. Our interactive demo at megamodels.search.sh visualizes state transitions in real time. Try to see component level consistency in action. Here is a URL. Here is our breakthrough demonstrated during order placement when inventory updates elsewhere. Traditional approaches cause order service to block. With Microflex, other services inventory becomes shared minus and continues operating with 30-second bounded staleness, achieving 40 to 60% throughput improvement with formal guarantees. And comparative analysis, unlike 2PC, which blocks everything, or eventual consistency, which risks financial inconsistency, Microflex provides strong consistency where needed with performance elsewhere. Our key advantages: component level consistency types, formal guarantees through precise transitions, preserve service autonomy, and developer-friendly framework are our improvements. Feature work, feature research. Feature work includes duplication optimization, extended consistency types, verification tools, and integration with existing frameworks, for example. Conclusion: we've broken the first dilemma between consistency and autonomy through formally grounded component level consistency control with measurable performance benefits. And thank you. I'm ready for questions. Our demo is available at megamodels.search.sh. And thank you, and sorry for the troubles you have with internet. Thank you.
Emilia ma'am, any questions?
Thank you for the presentation. So your application actually it's treating this consistency problem and also the application. For example, can I use it? Is it for everyone? For I don't know, for some specific data?
Okay. Actually, we have a proof of concept implementation, and it's not been in productions, but we are currently collaborating with industrial partners for production validation. So it can be used only for proof of concept actually, but not in production yet.
Okay, thank you.
Okay, thank you.
Anuma ma'am, any questions? There's a technical glitch from ma'am's side. So thank you, sir, for your presentation.
Okay, thank you.
Now, next, I would like to call Nicholas Lazaropoulos, sir, to present their study on probably efficient resource allocation of cloud native functions for network services.
Okay, thank you. Can you see my slides?
Yes, sir.
Okay. Good morning, distinguished colleagues, and thank you for joining me today at ICTIS 2025. It's my pleasure to guide you through our work on provably efficient resource allocation of cloud-native function for network services. Over the next 12 minutes, I will introduce and formalize the problem we studied, unveil while our two-step algorithmic framework, explore its performance in two settings, and conclude with future directions. Basically, we investigate theoretical guarantees and practical efficiency in placing cloud-native functions realized as sets of modular microservices into capacity-limited cloud workers. So let us begin. Cloud-native functions, or CNF, represent sets of loosely coupled microservices that implement network functions. ETSI Network Function Virtualization Release 3, which is a standard in cloud native and telecommunication deployments and packet core system for mobile network, gave rise to CNFs as first-class citizens of network service deployments. So you can imagine that CNFs are actually groups or sets of microservices. A microservice is a Kubernetes pod you're familiar with, or a bunch of Docker containers or something like similar. In addition, we also have a new technology named Service Mesh, which is a framework. It's a new standard that makes microservices capable to exchange messages in a stateless manner, and this is a means to abstract connectivity from microservices. So this brings us to the notion of having an abstraction in the connectivity layer and focus on resource allocation of microservices for cloud-native functions, which is actually a problem that it is proved to be NP-hard via well-known reductions to well-known problems of combinatorial optimization, like the generalized assignment problem and others as well, facility allocation, multiple knapsack, etc. So if we look at the existing work, and mainly at the work that focuses on legacy technologies, VNF, virtual network functions, it's a legacy part of virtualization comparing to CNFs. We find meaningful work around approximation algorithms for resource allocation that exploits reductions and algorithms that are related to multiple knapsack with assignment restriction, set cover problem, chaining, service function chaining, and also the group generalized assignment problem, which is also a problem that we will discuss in our framework. Let's recall the definition of the group of the generalized assignment problem. Generalized assignment problem means that we have a set of items and a set of knapsacks. Each item has a size and a profit, and we want to assign items to knapsacks in a feasible way. Feasible means that we do not violate the capacity of the knapsacks in order to get the maximum profit of this assignment. The group generalized assignment problem is an extension of the generalized assignment problem, introducing grouping constraint. This means that the items that we're going to place in our knapsacks have to satisfy groups, because we want to maximize the profits of the groups. We have two possibilities. Either the profits are assigned to the items or to the groups itself. In the generalized assignment problem, the profits are assigned to items. Okay, so now we thought that according to the ICTIS standards and the generalized assignment problem, we can describe the general capacity constraint resource allocation for CNF's problem. A CNF, which is actually a group of microservices, is satisfied if all of its microservices are assigned to cloud workers. A set of cloud workers is a cluster. Each microservice has a side that might be CPU out of memory demand, and we have a workload assigned to CNF, which you can imagine that it is the number of subscribers in a live network, or the packet flow demand that the CNF is supposed to process, or even a priority number, if you think about Kubernetes frameworks, which means that the CNF has an associated priority regarding the importance of the role of the specific CNF in the system, in the cluster. So the goal is to assign microservices to satisfy CNFs and get the maximum workload of these satisfied CNFs. Note that microservices may be isolated or shared among CNFs. Our proposal, our contribution to this work is basically a framework, an algorithmic framework that it can be used for many scenarios in order to maximize the workload. Initially, we select the CNFs that aiming to maximize the workload that these CNFs carry. Then, for the microservices, for the satisfied microservices, we find a fractional assignment based on a relaxed linear program to the workers, and then based on this fractional assignment, we construct a pseudo packing, which we'll explain in short. And then we convert this pseudo packing to a feasible assignment through an extended routing procedure. This algorithm is heavily based on steps 3 to 5 that, through reductions and proofs, these steps reduce the total workload by a factor of 1/2 compared to the fractional solution we get from the step one here. And this, in order for this to happen, we adopt some capacity constraints. And the capacity constraint is that we want to satisfy CNFs that have size that is at most half the cluster capacity. We state a theorem. So if we can have a better approximation algorithm to select CNFs, then steps 3 to 5 can guarantee a drop to our workload by half. So we get, with a total approximation framework, having better approximation, assuming that the CNF size, that each CNF's size is at most half the total cluster capacity. All workers are similar. They have capacity of 1, and the microservices have sizes in the range 0 to 1. And so if we have M workers in the system, the cluster capacity is M, and the half of it is half of M. So this is our framework, which we use in order to get to meaningful results. 1/2 approximation for isolated microservices, and another one approximation, a new result, which was not introduced before, for the approximation for shared microservices, for the case that microservices are shared between CNFs. So, to assign the selected microservices, again, after we select the CNFs whose workload is maximized, we use a linear. We have to assign a profit to the microservices. Remember that the profit of the problem is actually the workload that is assigned to the CNFs. So we assign a profit to the microservices that is proportional to their importance to the CNF's workload. Then we fractionally assign these microservices to the workers. We do an initial rounding to this fractional assignment by getting a pseudo-packing. A pseudo-packing is actually a non-feasible and an almost feasible assignment of microservices to workers, which means that, which allows for some overloaded workers, and we can find one microservice per overloaded worker that if we remove, then the worker has a feasible assignment. So we construct a pseudo-packing, and then we evict some items from these overloaded workers. We exploit the fact that we have used half the cluster capacity, and then we re-evict these microservices again to the available space by overloading the half capacity of our cluster. So we are still inside the feasible domain by simply allowing CNFs with half the total capacity to be placed. Then, if we apply this framework to the isolated microservices, we have a problem that it is equivalent to the grouped multiple knapsack problem, which is actually a case of the group generalized assignment problem. For this problem, there exists a 1/2 minus epsilon approximation from another analysis through dynamic programming, which we also get from our framework for microservices. But we have also the option to select the CNFs based by seeing them as sole items that we gather, and this can be also done by relaxed linear programming, linear program, and by this way we can get our tight approximation for the grouped multiple knapsack problem. So we end up here with two results. We verify the existing result, and we also get a tight result, and then we proceed with the assignment by defining profits for the microservices. Then we also have the
gentle reminder of you crossing your 10-minute mark.
Yes, we also have the shared microservices here, the case of shared microservices, where we actually see that the CNF selection part is equivalent to the set union knapsack problem, but with a special case. We adopt the existence of a bounded sharing degree D, which means that up to D CNFs can share microservices, and we end up with a new result here by using an existing work from discrete applied mathematics in 2014. Then we still proceed with a fractional assignment by assigning profits to the microservices that are equal to the proportional contribution of each to the CNFs. We also provide experimental study for this, which shows that our algorithm behaves well. Here in the left diagram, you can see that for a small number of microservices, we are significantly below the upper bound of our error, which means that our algorithm behaves well. And for large instances, which we cannot solve an optimal solver, an exact optimal solver, we show the upper bound of the relative error. And for a value of D, we see that this is below 50%, and this confirms the scalability resilience to high integrality gaps, since the relative bound experiences the integrality gaps in turn against the upper bound. So we propose the framework in this work, and then we also use this framework for two approximation. Our future work will target to also introduce assignment restrictions against the workers, connectivity constraints with sorted function chain paths, with and without energy costs, and an online fashion of our problem, and probably introduce this online fashion to an orchestrator setting like Kubernetes, OpenStack, or something else. So thank you very much.
Amelia, ma'am, any questions?
Thank you very much for your presentation. Actually, I was thinking about which you consider the main benefits of having this new framework, and also which was the most challenging aspect in developing.
First of all, this is a great question, and thank you very much for asking so. So this framework introduces the concept of resource allocation for CNFs, realizing them as group of microservices. This is the next layer, the next abstraction from service function chaining, because service mesh abstracts the connectivity. So this is a work that highlights the resource allocation by exploiting today's technologies in the domain of cloud computing. So we can exploit these technologies and use this framework to focus on the resource allocations, which is a very difficult problem in cloud environments, especially if you think about costs, energy costs, or whatever. So, and to answer your second question, the most challenging part was to implement our framework, our approximation framework, an implementation, and simply creating some modules that each one of them is supposed to perform the appropriate calculation of our algorithm that I showed. This was a really challenging task, I must admit.
Okay, thank you very much.
Anubha ma'am, any questions for sir?
No question from my side.
Thank you, sir, for your presentation.
Thank you very much.
Now, next, I would like to call Abdulaziz Al Khaje, sir, to present their study on ransomware
Question
resilient
पूछ लिया मैं
architecture
को
for healthcare using blockchain and IPFS. Yes?
Yes, hi. So I'll share my screen. So hello everyone. My name is Abdulaziz Al Khajab, and today I will present our project is ransomware resilient architecture for healthcare using blockchain and IPFS. And this is all my colleagues, Alia, Rakan, Sarah, and Suhail, and our supervisor, Dr. Deepa, and Dr. Joseph. So along with this introduction for our project creating a mitigate ransomware attack for healthcare, we choose this project because in healthcare sector, usually we are using to patient come to our hospital to secure the data. So in hospital now we're using a computer system to record the patient data. So what we did is to help and to mitigate the risk on ransomware attack on the hospital. So our project aimed to reduce this risk by using blockchain technique and IPFS to create a decentralized and secure storage system to ensure the continuous data availability and integrity. So attack rates have increased and have recovered costs during the pandemic. So basically in 2021, the attack rate on ransomware attack in hospital was 34%. And after 3 years in 2024, the attack rate had increased 34% to 67%. So these sources we have gathered in 402 health organizations and among 14 countries. So this state that the ransomware attack in hospital are very, very, very high impact. So we need to mitigate it and to create something to secure the hospital patient record and their integrity and confidentiality for the data. So what I'm gonna tell you about the current hospital system and our project approach. So the current hospital system, they're using traditional hospital system, which is rely on centralized storage, and centralized model are easy target for attack. Our project is offer decentralized system and using IPFS and the blockchain technique, which can be saved in the nodes and creating a unique CID. So this is the hospital and this is the server. Attacker can get access to it for the current hospital. Later, he can take the vitals and information. It can be secure, and then he can be asked for ransom. For our approach, we are using IPFS and Pinata Cloud for storing the patient information, which is be using by blockchain. So the motivation for this is for what our approach is to data distribute across multiple nodes, reducing risk of compression, and IPFS allow continuous access to patient data even during ransomware attack. So if, for example, ransomware attack happened, our system, our smart contract will prevent any the hacker cannot access any patient data because it will be decentralized and will be accessed only for the blockchain and will be tamper proof. So we have done more than research and literature review. The ransomware attack in healthcare can be like this is some studies happened, the hospital system shut down, appointment, admission, and ER. So are some studies happened when ransomware attack happened in the hospitals. Here, a comparison of traditional centralized system and our proposed technique as well. You can see for the data storage, data integrity, and data access, and data backup and resilience, what our project proposed more and ensure immutability for the system data. So this is our flow chart for our project we have created. So for example, the patient for the flow of the data will be saved in the blockchain. The patient will be visit the hospital, reception at the patient information, then it will be create JSON file, will be stored in the IPFS. If the information is stored or not, will be create a new account for the patient. Then it can be accessed, receive an IPFS hash, and going to the blockchain. Then we'll update the blockchain with reserved file for the hash. So this is the process I'll be explaining in the further slides. But this is the flowchart to know. As well, here's the network diagram for the architecture. We're using the blockchain, the IPFS system, and the Pinata cloud. So everything will be saved in the IPFS file system, will be as well saved in the Pinata cloud. So we're using the server provider, which is Pinata cloud, and it's gonna be will be updated by using the smart contract that we have been created to announce the roles for each for each system. So like owner, doctor, patient, receptionist. So that's all being created by doing the smart contract from the scratch. So you can see this is the role access control, the 4 type of user we have created for our project, which is owner, receptionist, doctor, and nurse. Owner can only create roles like receptionist, doctor, nurse. He cannot create the patient file. The receptionist is being authorized to create patient file and nothing else. The doctor can only make change in the patient file. For example, he can put the vitals for the patient. Patient has a heart disease, the vitals, what's the condition he's having. And the nurse only can make change in the patient file. She cannot create a role like the owners. So everyone have some role. So they cannot be access other authorization or so whatever. So the tools and technique we have used is MetaMask for the crypto wallet to authorize the transaction that we are making using a real cryptocurrency BNB. Remix ID, we use Remix ID to deploying and testing the Ethereum smart contract. BCS testnet, we use the decentralized blockchain used for testing supports native currency. So we use like BNB. So Solidity, it's a program language we use to create as our smart contract. Vitis, it's a web development we use to build the project and front end. The IPFS, it's a decentralized storage system for a large file like JSON data that we have used. Wagami is a library that's linked the web program, the web application, and our smart contract. And we have GitHub and Volatility. So here's our smart contract overview. We created the smart contract using Solidity to run the blockchain. So we run like the task we did for the doctor, for the nurse. So we did the rules and we put the unique hash for everyone. So everyone of our system, like the doctor, the nurse, the patient, they have a unique ID, which is CID. So that's we have created to put their roles to keep the data secure and ensuring the result the same across the nodes. So for the implementation part, so we use the GitHub desktop to put our all information to put our system there in the GitHub desktop. So if we want to make change, take a snapshot or something, if we're gonna make change in the code, we will execute it here. Netlify CID pipeline, it's to see the implementation part, what is going to happen to set up the program. Here is the implementation. You can see here is the owner page. So the owner, you can see he can select the picture, and he can custom. He can put the picture, then the names and the role. Here he can select the role. Who can be access this? The doctor, which doctor? Date of birth, here's the address that we are using, which is the unique identifier for each person. So if the owner gonna create a role for receptionist, he should add the address for the receptionist to make it secure and to make it unique. Then here's the receptionist page. She can create a patient file, put whatever. Then she can select the doctor and select the nurse. So if so the patient, if he come in our hospital, he will be assigned to a particular doctor and particular nurse. So not every nurse and doctor can see their information. So for example, if the patient come to our hospital and he have, like for example, for the first time, the receptionist will register all the information. Then the doctor, when discharge the patient, the doctor cannot see and revise the patient record. خلاص, it's done because it's gone, and he cannot access it until the patient come again to the hospital. So basically there'll be a sign, so there is no temporary proof or something if that's happened. You can see here's the currency that we're using, BNB, TBNB, which where we're using the transaction. We need to confirm by using MetaMask. This is the receptionist. Later, here's the nurse page. You can see she can put the vitals for the patient, weight and height. And you can see the doctor assigns Dr. Deepa. And for the doctor page, he can diagnose the patient, prescription, patients in charge or discharge. So he can use this stuff that we have written there. Then here is the one that's going to show in Pinata Cloud that we are using. So to secure the information, you can see here's all the patient information, patient ID, patient title, first name. So I
Excuse me, sir.
here's the, yes.
Gentle reminder that you've crossed your 10-minute mark.
Okay. So here's the patient ID, title, first name, last name. So you can see everything. This is the address that we have used to create the patient. And this is the unique identifier. So we require to compare the hash between this one and the old one to see if there is any change or modify. But as you can see, there's not. So we compare it here in the BS scan, the same address. And here's the transaction that's going to show on the blockchain. So the data review, the retrieval and update, the secure data, we're using patient data set by JSON file. So the control system, we use the authorization doctor and nurse to retrieve the data using CID. Everyone will have a unique identifier. Updating record, when updating we need file using re-uploaded. So patient, doctor or patient cannot update it unless if they are in the hospital. Here is the experimental setup that we have done using a ransomware attack. So I tried to hack the system in our smart contract. So like you can see, I did this is the innocent hacker. After that, I changed the Solidity program in the smart contract. Then I run it. Then you can see our local host, the website. It's gone. It's showing this is the innocent hacker. So this is the ransomware attack. So we cannot access anything from the system. But what happened, we retrieve it, we can see the hacker cannot access anything in the system. He just hacked the website. So nothing happened. He can't access the patient data, database, whatever. He cannot access that. However, we retrieved that and everything got backed and the system all is working after the test. But the hacker cannot access any data. So for result and discussion, using blockchain, the IPS makes secure patient data is safe, cannot be changed by the hacker. Only unique digital footprint and fingerprint can be used. Access control, we use the smart contract to make sure that only right people like doctor and nurse can access the data. For the future enhancement and limitation, the system is already strong, but if we adding AI to detect unusual behavior and using zero knowledge proof, can make our system stronger and solve more issue like slow access time to save encryption management. So that's this. Our study present a secure, decentralized framework using blockchain and IPFS Pinata Cloud to protect healthcare from using ransomware. So this is our project, and hopefully it's going to be good if we sell it somewhere. Thank you so much. Any question?
Amelia, ma'am, any questions?
Thank you for the presentation. Your application indeed looks very good. I was thinking about the testing of the application. Did you do that practically? I don't know, in a clinic somewhere, or it's the next step.
It's going to be the next step. But the question was, we have run the testing in our system, the Solidity program. So we have run it to check if, like, the hacker got access to the system, what's going to happen? What's the ransomware that's going to happen? Like, what's the data that she can steal? But eventually, it's just the web program. It's going to be shut down, and he cannot access anything. The data will be secure in the blockchain eventually. So basically, we done it in our system, in our server, but we haven't done it in the clinic or hospital yet. This will be the next future approach, hopefully.
Okay, thank you. And one last question. You told us about the security, about how you secure the data. Are you going to store also a password or just fingerprints and that's all to make sure everything is perfectly safe?
We will try to upload try many mechanism as well, but for encryption we're using the encryption AES 256 for the security, for securing the system. But for the password, like the patient record is very important to us, like the ID and their information, the virtues and stuff, so we're keeping them safe, hopefully. But yeah, we're trying to keep it strong. We'll use
Okay.
multi-factor or authentication, that stuff.
Yeah. Thank you very much.
Thank you so much.
Anubha
Uh,
ma'am, any questions?
yeah, it's a very good application, properly implemented. So I must congratulate the researcher who has done it. I agree with the professor that proper testing is required for the system. It's a must.
Mhm. We will
So,
try it, but
yeah, until unless it is tested well, you cannot deploy it in the real world, isn't it?
we haven't tried to upload it in a real world yet. But we are planning to do that. But the thing is, we tested already, because we tried and we created the smart contract from scratch for the role access, for the role accessibility and stuff.
Okay, thank you.
Welcome.
Thank you, sir.
Thank you.
And now, with this, we've concluded with all our presentations. I sincerely thank our authors for their excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the whole team, thank you for the support during this 10th version and all the previous 9 versions of the conference. All the presenters will be getting their digital certificates through email within 2 working days. The publication will be live within 6 to 7 months. Hence, kindly cooperate with the team of ICTIS 2025. I would like to thank our session chair, Professor Amelia Pop, ma'am, for chairing our session. Thank you so much, ma'am. And I'm sharing a token of appreciation on behalf of Team ICTIS and Global Knowledge Research Foundation and partners. Please share any closing remarks you may have for us, ma'am.
Thank you,
First of all,
Demai. Yeah, sorry for interrupting. Yeah, thank you, Demai. It was a very well planned session, and I congratulate all the researchers for doing wonderful research. Uh, we really loved the research and the implementation work done by all the researchers. I wish them all the best. And I congratulate the organizers of GR Foundation, Dr. Amit Joshi and Dr. Mihir Chauhan, for taking this conference all the way to US now. I really congratulate them and wish all the best. Thank you.
Thank you, Dr. Anumajan. And I would also like to thank Amelia Pop, ma'am, for chairing the session. Ma'am, please share any closing remarks.
I would like to thank you very much for this amazing opportunity, for having me here. It was a pleasure and an honor for me. I would like to thank to the entire ICTIS team. And also, I would like to thank to the participants. The papers that we have listened today were amazingly and from various fields. And once again, thank you to everyone. And I wish for you the best, and God bless you.
Thank you, ma'am. Now, I kindly request everyone to turn on their camera for a quick snapshot of this virtual conference. All right. Thank you, everyone. Have a great day ahead. Thank you.